Let's start going over some of the homework problems from 7.1. So in this first video, I'll go over 5, 17, 19, and 21. So let's look at number 5. Uh, we have f of x equals 3, parentheses, x cubed minus x. So we need to, the problem is asking for us to set up the definite integral giving the area of our region. So we may need the help of a calculator to kind of so we can visually see this graph. So we have a cubic function, y is equal to x cubed minus x. We see that it goes above and below the x-axis. And then our second graph is this 0, y equals 0. So the shaded region is the enclosed region created by these two graphs, and we see we have two shaded regions here, one that's above the axis and one that's below. Okay. One thing that we know is that f of x is an odd function, and so the area regions are going to be equal to each other. So if we find the area of this region, we've also found the area of this region. They're going to be equal. So if I want to find the area of these two regions, I can just find one area and then just double it. So that's exactly what we're doing here. We're going to, or we can think of it as we're adding two of the same equations to each other. So we're technically going through the top curve minus bottom curve rule or formula. Top curve is this cubic x cubed minus x, and the bottom curve is the 0. So minus 0 will just go away, so we're just left with 3x cubed minus x. We add the two together, or we can just double it, and we have, if we double our first region, then we can say 2 times 3 is 6. So we can say the area is 6 times the definite integral from negative 1 to 0 of x cubed minus x. All right, 17, we may actually need the help of using our calculators. We have our graph. First function is 1/2 x cubed plus 2. And the second graph is the x plus 1. Now, if we graph these two equations, we're going to see that this x cubed plus 2 is consistently the top function in the interval from negative 1 to 6, always higher, always above this x plus 1. So we know we can do top curve minus bottom curve because we see consistency from our left bound to our right bound. This is always the top, and we have one consistent bottom curve. All right, so we set up our formula here. Our area is our left bound, which is 0, and our right bound, which is 2. And we can do that simply by setting these equations equal to each other and solving for x. Okay, so the top function is 1/2 x cubed plus 2. The bottom function is the x plus 1, so it's top function or top curve minus the bottom function. Okay, and then we just take steps to combine terms. And then once we do that, then we apply the appropriate rule. All these will be Powell rule. So we have 1/2 x to the 4th over 4 plus x minus x squared over 2. And then we simply evaluate our upper and lower bounds. Okay, 2 plugs in for all the x values. And then we minus, then plug in 0 for all the x values. And then we're left with 2 plus 2 minus 2, which is a positive 2. All right, number 19. We have our function x squared minus 4x, which is the parabola here, y equals 0, x-axis here. So the shaded region, we see here, and we need to be able to find the bounds so we can be able to plug into our formula. So we take and we set the two equations equal to each other, and we find our left and right bounds by solving for x. So x squared minus 4x is equal to 0. So we simply factor the x out and solve for x, so 0 and 4. So we see that our left bound is 0, our right bound is 4. So that's exactly what we plug into our formula. Okay. Now the top function in this case is going to be this y equals 0. And the bottom function is this x squared minus 4x. As you see, this curve is consistently below the x-axis for the entire interval from 0 to 4. So top function is 0, bottom function is x squared minus 4x, and so that's simply going to be negative. Distribute the negative through, negative x squared plus 4x. We go through power rule, evaluate between our upper and lower bounds, combine terms, and we get our area, which is 32 over 3. All right, 21. We have our function x squared plus 2x plus 1, which will be our parabola here. And we have the 3x plus 3, which is our linear function here. So we need to identify our left and our right bounds. So set the equations equal to each other. We're going to get two answers, two x values. First, we can just go ahead and move everything over to the left side, combine like terms. We can now factor, solve for x. So this factors out to be x minus 2 and x plus 1, which is x equals 2 and x equals negative 1. So our left bound is negative 1, our right bound is a positive 2. Okay, so now we want to plug into our formula. Left bound, negative 1, right bound, 2. Identify the top curve, the top function, and between these two intervals, the top function is always going to be this 3x plus 3, so that goes in place. Minus, now we plug in the bottom function, which is the curve, x squared plus 2x plus 1. And then we simply combine the terms here, and combining like terms, we get negative x squared plus x plus 2. So then we apply power rule for each term. Negative x cubed over 3 plus x squared over 2 plus 2x. Then we evaluate between our upper and lower bounds, plug 2 in for each of the x values, minus, and then plug in negative 1 for each of the x values. Make sure you put parentheses around those to help remind you that this negative will distribute to each term. And then we combine, add the terms together, we get 9/2. That's our area between the two curves between the left and right bounds.